Hi, in this video, I want to discuss something called the final value theorem. Um, let's say you know the transfer function of a system, and the transfer function is given by this equation. And of course, the transfer function is in the S domain. Is there a relationship between the transfer function and the time domain uh, output? Of course, there is, right? You can take the inverse Laplace transform and go to the time domain. But in certain cases, you can know something about the time behavior of this system even without doing a complete inverse transform. So one of the things that you can calculate directly from the transfer function is the final or the steady state value of the system. So the steady state value of the system is given as is the value of the system when time is infinite. So basically, if there is a change in the system, so let's say what you do is you displace this mass and then you leave it, okay, or you apply a constant force and then you wait for the system to kind of equilibrate, and you wait for a very very long period of time. So what would happen to the output? What would happen to, let's say, the displacement in this physical system? So we can calculate that without doing any complicated calculations. If we know the transfer function, we can just get it by using this equation here. And this equation is called the final value theorem. So in this case, what we would do is we would say limit s tends to 0, and the transfer function is given here. So s times that transfer function. And now you put the values of s equal to 0. So you see that what you would get is 0. So the steady state value or the final value of your system is 0. So basically, the system in this case seems to be coming back to its equilibrium value.